Chapter 10, Network Segmentation and Virtualization, Part 2. So when we left off in our first lecture, we had just covered classful networking, right? We had gone in and we had shown how expressing my decimal IP address and subnet mask in binary, it didn't get any prettier. I'm sorry, it's still pretty ugly, but you get the idea. Expressing this in binary versus decimal really makes it clear how this whole thing works, where my subnet mask with its range of contiguous ones tells me where my network identifier is. Now, it's kind of easy on classful networking, honestly, even from decimal, right? Because an entire octet is either treated as all on, or all off. So I have a choice of 0 or 255. So in this example, right, this is classful. Anywhere there's a 255 where the octets line up, it's network. And that was fine and everything. But look at our network classes that have millions of hosts in them, or tens of thousands of hosts in them. Honestly, we can't have networks that big. The broadcast traffic alone would kill us. The whole intent of these Class A and Class B, and also even Class C networks, is to give us something to subnet, to cut it into smaller pieces that then we can turn around and make use of. And that's actually what the term sub-networking means, to take a network space and cut it into a smaller, more bite-sized, manageable chunk. Well, let's pull back up over here. Where'd you go? There we go. Classful networking only lets me go down as far as a Class C, and that's it, right? I can't get any more granular than that. My smallest network space I can get with classful is 254 assignable IP addresses. What if I have a need for a network smaller than that? A lot of times in networking, there's a picture of our routers right here. When we connect routers together, this connection right here that connects router A to router B is called a point-to-point connection, which means there's only 2 points on it, right? This network, and this is a network right here, that connects this router interface to this router interface will never get any bigger than that. It's always 2. Well, am I going to throw away an entire Class C network with 254 hosts in it just for those 2 addresses? I can, and quite frankly, a lot of organizations do that. A lot of admins do that. But it's considered sloppy, right? Even though it's a private networking space and I got millions of addresses to pick from, and I probably won't run out internally inside my own local area network. Yeah, I could do better. So what if I take my Class C network and carve it up into smaller pieces to, let's say, only give me 2 assignable IP addresses? I'll have a network of 4 possible IP addresses: the network ID, an assignable IP, and the broadcast address. Well, I can totally do that. And that's what subnetting is. But from there, I'm no longer classful. Now I'm going to classless networking. Let's take a look at what that looks like. Let's do just this. Here's our same representation, right? And I'm going to do something crazy here. Actually, it's not very crazy, but roll with me. I'm going to subnet this network. So instead of having one network with 254 possible hosts in there, I'm going to cut it down so I have 2 networks with 126 possible hosts. Let's do a bit of, write this in here. Let's try that again. There we go. Look what I just did to my subnet mask. 255, 255, 255, 128. Yeah, here's what I actually did. I'm borrowing 1 bit from the last octet to be used as a network identifier. I'm effectively doing this right here. Notice the dots where my octets are still divided. Octet, octet, octet. Only now my subnet mask doesn't stop on the dot of the last of the between octets 3 and 4. Now it goes over 1 into my last octet. If that's the case, how many bits do I now have to represent my network? Well, 8, 16, 24 plus 1, 25 bits. So I have a 25 bits for my subnet mask now. There's no such thing as a free lunch. If I gained a bit for my subnet mask, I took one away from my host ID. So now how many zeros do I have left? How many zeros that represent the host ID? 1, 2, 3, 4, 5, 6, 7. If I'm going this way, I'm cutting my numbers in half. So if originally I could have 256 original values, including network ID and broadcast ID, going over one direction now cuts that in half. So now I've got 128. I have a network of 128 values minus the network identifier minus the broadcast. That gives me 126 assignable IP addresses. Look how I got my decimal subnet mask, right? I lit up this ones position over here, so it just makes it over here. All you do is you add them together, right? I'm going to expand my drawing area over here. Expand that a bit too far. Can't see my tool set. There we go. So to represent this, if this block right here represented my original Class C network space, right, it's represented 192. It's a 9. 168. .1 network with a 24-bit net mask. That means my first assignable IP address would have been a 1. My broadcast would have been a 255. And there we go. But I cut it in half because I borrowed a bit from here. I took the same space and I carved it right down the middle. So now in my first network, my first assignable IP address is still 1. I got 2 networks here now. I've got 192.168.1 dot, and I've got one. Oops, I'm still on the wrong tool. Still on the wrong tool. 92.168.128. That's my second network. Now the IP address 192.168.1.128, I messed that up. Let's get out of that. My handwriting's so bad on this online whiteboard that it's kind of hard to even see what I'm writing down here. Come on, let's get the eraser out of there. There we go. You know what? I'm just going to write it right here inside the network. How about that? That's an 8. There. So 192.168.1.128 is no longer an assignable IP address. It's now the identifier, the network identifier for this second network. Let's look at what that does to our IP addresses. In our first network, 192.168.1.0, my first assignable IP address is a 1. But if the next network starts at 127, my broadcast becomes 127. 192.168.1.127 is the broadcast address for this network. That means my assignable IPs run from 1 to 126. Over here in my second network, if 128 is the network identifier, 129 is my first assignable IP address, and my broadcast is still 255 because it goes all the way to the network range. So my assignable IPs are 129 to 254. These are two separate networks. These are two completely separate networks. It's just like when we were looking at this picture right here. Right? One of those networks could be on this floor, one could be on this floor. The only difference is now they're smaller. Instead of having 254 hosts in them, I'm down to 126 possible hosts in each. It's kind of like going to the deli and buying like a big piece of salami, right? And I bring it home, and I'm not going to eat the entire piece of salami myself. So I'm going to cut it in half, eat the first piece, put the second piece back in the fridge. I still started, even if I just cut it in half, I still have that same area. The salami takes the same amount of space, only it's in two pieces now instead of one. That's all we've done with this network. All right? And we can totally keep going from here. What if I go and borrow another bit? Now what have I done? Well, let's look to see how many bits my subnet mask is. 8, 16, 24, 25, 26. Now I have a 26-bit net mask, right? What does that do to my decimal notation up here for my subnet mask? That changes. Let's get rid of that. Let's see, I add them together, 192 plus, or 128 plus 64, 192. So now my subnet mask is 255, 255, 255, 192. Let's look up here. And there's a little shortcut you can use when you do this technique. If I look where my ones position is, and go straight up, that's how many values I have in that subnet space. -2, network identifier and broadcast address. So now what I've done is I've carved this network space into 4 networks of 62 hosts each. And I'm just going to cut this one up just for an illustration. There, that's pretty cleaned up. Right down the middle. Now I've got, if I cut this one down the middle also, 4 networks in the same space of my original Class C network. 4 networks of 64 hosts. And it makes sense, right? If I went from 128 the last time and I moved to the right, because when we move that direction, we cut in half, then I went from 128 to 64. Notice again, I have this nice little helper right here, right? Always write out your bit positions. It's so much easier when you do this. What does that do to my IP addresses now? Well, my network identifier for my next network is 192.168.1.64. That's no longer an address I can assign. My first network, my 192.168.1.0 network, which is still there, what's its broadcast address now? Well, now its broadcast address is a 63. Assignable IP addresses, 1 to 62. Second network over here, the 192.168.1.64 network. First assignable IP address, 65. Broadcast address still remains 127. So my assignable IPs in my second network, 192.168.1 to 65 to 126. And on and on and on. And I can keep doing this. I can keep going. Oops, wrong tool. Steal another bit. All right, now I have, that was a 27-bit net mask. Now I've got a 28-bit net mask. And what does that do to my decimal? Clean this up. Add up the ones. 128 plus 64 plus 32. Carry the 1, 224. And again, I just cut my available space in half yet again. Now I've got 1, 2, 3, 4, 5, 6, 7, 8 networks in the space of my original Class C network, my single Class C network. But now how many hosts do I have? Look up here, 32. I have 8 networks that can hold 30 hosts, 30 assignable IPs. And we keep going. I can keep going all the way down to where I get a 30-bit net mask. If I do this, I erase all these zeros, I keep right on going. There we go. If that's 28, 29, 25, 26, 27, 28, 29, 30. Remember we talked about point-to-point networks? Where I'd have 2 routers together and I only need 2 possible IP addresses? Well, look what a /30 gives me. Line that up. 4 possible values, minus 2. 1 for the broadcast address, 1 for the network identifier. 2 possible IPs. Point-to-point network. Now you're like, what's with that /30 thing? What's going on with that? It's called CIDR, classless interdomain routing. And it refers to the CIDR notation. Instead of having to spell out my network mask long like this every single time in full decimal notation, and when you're doing network documentation, this can get tedious really fast. Especially if it's not classful. Right? I got 255, 255, 255, 224, and on this next one it's 255, 255, 255, 240, or 252, or whatever. CIDR is a shorthand. And really all it does is it's the IP address with a slash and then the number of bits that are in the subnet mask. So if I got my original block of ones here for my subnet mask, how many bits in it? 8, 16, 24, 25, 26, 27, 28, 29, 30. I represent that my IP address 192.168.1.100/30. And that means 255, 255, 255, and in this case 252. There's lots of new concepts in here, and I admit IPv4 subnetting does take a lot to get one's brain around, especially if you've never done it before. I can't stress it enough. You need to practice this. These IPv4 subnetting skills are required in the routing and switching course, and they're going to be required pretty much every day on the job as a network administrator. Take your time with this. Please practice it. There's lots of online resources. Subnettingpractice.com is one that comes to mind. There are also subnetting calculators available online, although I highly encourage you to not use those to solve your subnetting problems. I mean, use them to learn the concepts, but really you need to practice. You need to get to where you can subnet pretty much on the fly. As always, if you have any questions, please feel free to reach out to me, and I will see you next week.